geometry students. I hope you guys are doing awesome. Well, we are beginning chapter 4, which I think you probably are all pretty happy about because, as I'm sure you've heard by now, chapter 4 is going to be primarily taught through using art. Now, there's going to be two components to what you have to turn in every day in chapter 4. The first thing is you need to turn in a picture of your notes from the videos for each night. So you'll be getting 5 points just for turning in a piece of paper with the correct information on it showing that you watched this video. So that will be 5 of your 10 points every day. The other 5 points is going to be from showing me a picture of a photo that you have cut out of a newspaper or magazine or advertising flyer that demonstrates the concept that the notes are about. So I'll explain more to you during our Zoom session, but I wanted to go ahead and get you started on your first notes for chapter 4. So all of these sections that we're doing are on things called transformations. And basically what that means is we are manipulating points. We're either sliding them, flipping them, rotating them, stretching them. We are taking geometric points and shapes and making transformations to them. So the first topic that we're going to talk about, and this is what you're going to put at the top of your notes for 4.1, is called translations. Translations. So that is what the topic for 4.1 is about. So I'm going to do several examples to show you what translations look like in the math context, and then we will review those in our crib sheet review during Zoom. And then after that, we will talk about the artwork you need to do for your homework, okay? So first of all, I'd like to show you what a translation vector looks like. So let's make this be example 1. And what we're going to do is we're going to show a point J here, and then another point K, and we are going to show the translation vector from J to K. So basically, a translation vector kind of looks like a ray, but it is a way of showing movement. Now, if this were on top of a grid, and I think what I'll do is perhaps use a pink pen to make this a little bit easier to see on your video. So imagine that this is on grid paper, and I was asking you to describe the translation vector. What I'm basically asking you is how am I moving as I go from J to K? So what we would do first is look at, just like with our regular points, we look at the X first. So to go from J to K, I have to go 3 to the left. So we don't write a parentheses for a translation vector. We do something that's more pointed looking, more like a bracket, I suppose you might call it. It's called vector notation, but this is the mark we would put down, and then we would put a -3 to show that we moved 3 points to the left. And then we would have to go up 1, 2, so I would put +2. So this is a visual of the translation vector, and this is a description of the translation vector. The translation vector from J to K takes us 3 to the left and 2 up. So it's a relatively simple concept where you're basically counting out spots. Now, let's try another example. Let's call this example number 2. If you do have graph paper, it will probably make it a little bit easier for you to do this. However, it is not absolutely necessary for you to have graph paper. So let's go ahead and plot some points. We want to look at triangle FGH, where F is at -2, -6. So let's go to the left 2 and down 6. 1, 2, 3, 4, 5, 6. Left 2, down 6, and that is point F. And then G is at 3, 0. So we're going to go to the right 3, put a point, and label that G at 3, 0. And then H is at 1, -4. So I'm going to go to the left 1 and up 4 and put a capital H, left 1, up 4. Then I'm just going to connect these 3 points. So we have now graphed a triangle with the appropriate coordinates. Now, when you are talking about a transformation, your original figure that you're looking at always has just regular capital letters for the vertices. Once you move that figure, then your new shape is going to have little tick marks or prime marks on top of the letters, and I will show you what that looks like. I'm going to use a different color for the translation. Now, it says if we want to translate using the vector -2, +7. If I wanted to translate triangle FGH, the one we just graphed, using the vector -2, 7, can you guess which direction I would want to go first? Would I want to go left or right, and how many would I go? So because it's -2, we are going to go to the left 2. So we're going to take each point and go to the left 2 and then up 7. So for example, this point here, F, was at -2, and I'm going to make it go all the way out to -4 and then up to +1. So point F prime, you can see the little tick mark there, is at -4, 1. Now, if you prefer, you can do this algebraically. If you look at point F being at -2, I can just subtract 2 to get -4. And here, if F was at -6 and I added 7, I would get +1. So you can either do it visually, if you're more of a visual learner, counting it out, 2 to the left and 7 up, or you can do it algebraically. If you prefer the algebra, you would subtract 2 from X and add 7 to Y. Let's try that with point G. If we were at 3 and subtracted 2, that would mean we would end up at 1, or we're moving 2 to the left. And if we were at 0 and added 7, we would go 7 up. So now we are going to be at 1, 7. So I'm going to put a dot here, and I think I'll put that in purple. And that's going to be G prime at 1, 7, at the point 1, 7. See if you can translate point H using the translation vector -2, 7. H is currently at -1, 4. So what you should have done is either on your graph paper counted 2 to the left and 7 up, or just done the algebra. If H starts at -1 and I subtract 2, well then that means I need to be at -3. And if I'm starting at 4 for my Y value and adding 7, I'm going to be up at +11. So my new H, or H prime, is going to be, instead of -1, -3, and then instead of 4, 11. So at -3, 11. And then I'm going to connect all 3 of those points. So I have now formed a new triangle. Notice that the size of the triangle has not changed. There's only one transformation we're going to talk about that changes the size of the shape. Our triangle should be exactly the same size. It just has been moved from its original spot, 2 to the left and 7 up. Okay, we're going to do some more examples. Again, you're not going to have to do worksheets on this, so this is really your only opportunity to process the more mathematical aspect of this. So example number 3 is going to ask us to find the component form of the vector that translates A, which is at -4, 8, to A prime, which is at 7, -9. So take just a moment, if you can, and see if you would figure out what the vector needs to be. And remember, we're going to use these little brackets like that to put our numbers inside, and there's going to be a comma here. I'd like to know, what would these two numbers have to be if I wanted to go from A to A prime? So take a minute, see if you can maybe get started on the X or the Y, and then I'll help you with it. All right, so what would I need to add to -4 to get to 7? What would I need to add to -4 to get to 7? I would have to add 11. So I'm going to put 11 in the X spot. And then if I was at +8, but I needed to go to -9, would I be adding or subtracting? And then how much? I would need to subtract, and I would need to subtract 17. So this would be the vector, this is the component form of the vector that translates A to A prime. Okay, let's do one last example. Example number 4. This is another way of writing a way to translate a point. It's using the coordinate pairs. So if we want to translate x, y, if these are our directions, to x minus 4, comma, y plus 3, we want to use that translation to find the image of the given point, and I'll explain what that means. G is at -2, 4. Our original point when we're talking about transformations is always called the pre-image. So like, if you're going to be watching a movie and you see a preview, the preview of the movie is what you see usually before you actually watch the movie. So the preview comes first and then the movie comes second. It's the same way with the translations. This G right here, we would call the pre-image. And then after we translate it, according to the directions that we've been given, we would call it our image. And so they're wanting to know what is the image, and that would of course be G prime. Now this is a fairly straightforward section. We basically want to do exactly what the math says. These directions say for every x you need to subtract 4, and for every y you need to add 3. So if you can, pause the video for a moment and see if you could figure out what would be the image, or G prime, if G is -2, 4. Think for a minute and see if you can figure out what the image would be. Okay, it says to subtract 4. So if I started out at -2 and I subtract 4, then I would end up at -6. For the y's, it said to add 3, so if my pre-image y coordinate was at 4, and I add 3 to that, I would end up at 7. So that point would have been moved 4 to the left and 3 up. Now, when we demonstrate our knowledge of this topic using a magazine picture, you are going to be asked to draw a translation vector. And I will give you specific examples of that during our Zoom session, but I wanted you to understand the math behind the translation vectors also. All right, thanks for watching this video. Be sure to remember that you need to upload your notes from this video into Google Classroom right where you saw this video. Thank you.